Okay, when I first used this site, it was kind of tough to get used to, mainly because the instructions over here are kind of vague. So you are going to need to read through this. It's got some information that has to do with the analysis questions at the end. The one that I didn't go over during the last section was what an unconformity is. And an unconformity is simply some sort of geological event like erosion or earthquake with a fault causes the rock layers to get out of order. Okay, and that's again called an unconformity. That was in the last section's notes. So you are going to need to know, you are going to have to go through this information over here to answer some of the analysis questions. But once I learned how to use the site, it's actually pretty neat. So it does have to do with law of superposition, and it also has to do with radioactive dating. So the first thing I'm going to do is I'm going to take my little nail here and I'm going to mark my layers. Okay. And then what I'm going to do is take my magnifying glass and I'm going to put it over the layer slowly until I find a fossil. Okay, so there's a fossil. It's like a snail shell. Okay. And then I go to the next layer. And, oh, there he is. Okay, so you got to go kind of slow to find the fossil. Okay, now I'm going to use the computer over here. You got to know what type of layers these are. So field guide. Okay, so this rock is igneous rock. Okay, and then this rock right here is the sandstone. Okay, this is an example of sedimentary rock, and those are the only ones that contain fossils. Igneous rock is the only one that you can radioactively date. Okay, and the reason for that is sedimentary rock is a mix of all different types of rock, all made at different times. So you can't radioactively date this. But igneous rock was all formed at the same time. So you can radiation date the igneous rock. So I found my fossils. Okay, I can go to my field guide and I can find out what fossils they were. It was a snail shape and then what's called a trilobite. So it was, oh, this one, okay, it's fossil V, and you would put that under your, on your table, and it lived during the Triassic time. And then I skipped the one from the last one. Okay, so this one. Okay, it's fossil S. It's not a real name, it's just fossil S, and it's found during the Paleozoic era. Okay, so I have included some pictures of the field guide, so you don't have to go back and forth between the computer and the field guide. Otherwise, you got to go back and go through all the fossils again. I did include pictures of the field guide to reference, and I've also got a picture of a geologic time scale that you're also going to need for the assignment. So I'm going to go ahead and close that. I'm going to take some rock samples. From the different rock layers. Okay. Then I'm going to come up here. I got to send these two layers, actually all the layers, but you're only going to get radioactive dates from layers 2 and 4. So I'm going to go up to the window here, this lady right here. She's going to collect the data for me. Okay, I'm going to give her the rocks. Okay. I click her again.
Expect the radiometric dating data in about 2 weeks. Check your email from the Geochronology Lab often.
Okay, so she's going to drive away. And when she drives away, I can go check my computer and check my email. Okay, it was only done on the igneous rocks, okay, because the age of the sediment doesn't really matter. So I'm going to go to next. Okay, this is layer 2. It's isotope D. The half-life, not half-line, half-life is 100 million years. So check out how this works. It's just like the graph from your interactive notebook assignment. Okay, it's going to go down. Here's one half-life. Here's another half-life. And here's another half-life. So it's gone through 3 half-lives. The half-life is 100 million years. So this would be 100 million, 200 million, 300 million years old. So that rock layer is 300 million years old. I go to next. This is layer 4. Its half-life is 250 million years. So this would be 250 million, 500 million. So that is the age of those rock layers, and you just put those on your table. Okay. Once you have that, oh yeah, just a side note, the dig sites aren't necessarily in order, so make sure you put them on the right table. And then you reset, and it's going to give you a new site to go to. Okay, so what I did notice is sometimes you have to reset the whole page, which is kind of weird. I don't know why that is. If this is sort of light colored, it means you can't put the stakes in, but I think you can still put, yeah, you can. You can still put the rock layers in there. You don't have to necessarily use the stakes. But this is dig site 1. Again, you're going to look for fossils. You got to go slow so that, you know, this isn't going to work. You can't do that. You got to go slow to find the fossils. But that's it. Okay, so the ones that are blocked out on the table, you don't have to fill in because, you know, igneous rock also doesn't have fossils in it because it's formed by lava. If there's any fossils in that area, they are completely destroyed. But that's how it works. Okay, so if you have any questions or trouble with it, just go ahead and let me know. But yeah, that's why there aren't many instructions on the worksheet, because I want to make sure to go over this with you. Make sure to change your font color to red and write in complete sentence with the questions. Okay, so again, any questions or problems, let me know. Okay, take care.